Now we're going to talk about terminal points. We find a terminal point by walking a distance along the circumference and then stopping. So for example, we're walking along the outside of the circumference and we stop at this location. We've stopped, that's a point. And the point has coordinates of x and y. Now, notice we traveled in a positive direction to find that terminal point. You can travel in a negative direction. If I traveled in this direction, I'd be traveling a longer distance around the circumference, but I could end up at the same location. It would have the same point, it's just the place where we stop. So the next thing we want to do is talk about how to name specific points when we travel a certain distance. So, let's think about this. Our radius is 1 because this is a unit circle. So the circumference of a circle, remember, circumference is 2 times pi times the radius. Our radius is 1, so the circumference of our circle is 2 pi. If we travel and have a terminal traveling point going pi units to get to it, then we will have gone halfway around our circle. When we have traveled pi units, we end up at this terminal point. This terminal point is -1, 0. We would have gone 1 unit backwards on the x-axis and we have no height, so it's -1, 0. Let's look at another terminal point. Our next one, -pi. That sounds familiar. But we're not going in a positive direction for pi. We're going to go in a negative direction for pi. So here we go. Remember, last example, we had numbers that were positive and numbers that were negative. Well, when we start, if we're moving in a positive direction, we move through the positive numbers first. If we're going to go in a negative direction, we move through the negative values of y first. So this time, since we're going -pi, we're going in a negative direction. We're coming around a circle, pi units is halfway, we end up here. That's the same terminal point whether we have gone pi units or -pi units. Now the problem is they don't always turn out to be the same. Let's take a look at another one. Whoops. Let's look this time at pi over 2. If I'm traveling to pi over 2, well, my whole circle is 2 pi. Half my circle is pi. So half of that would be to here. Pi over 2 goes to this location. Now, think about the normal coordinate axis. If we did that, since this is a radius of 1, we're at 0 for x and a height of 1, so our terminal point is 0, 1. Now, if I change this and say, let's go -pi units. -pi over 2. Remember, the negative means we're going through the negative points first. So we're going down, -pi over 2, we land here. And that, -pi over 2, is 0, -1, because we're below the center. Next one. I want to travel, I'm traveling 3 pi. Well, this is a little strange. Our circle's 2 pi. That means we're just going further in a circle. So we're traveling around. Halfway is pi units. The whole way is 2 pi. So if we want 3, we're going to go through it again and stop here. This is 3 pi units. 3 pi units stops at the location -1, 0. So -1, 0 is our terminal point. We travel a distance, and our distance is given by t. In this case, it was 3 pi. Where we end up is the terminal point, and the terminal point in that case was -1, 0. Now, let's look at something just a little different. We're going to travel a distance of pi over 4. Pi over 4 is halfway between 0 and pi, so it's exactly here. Now, if we were using your trig trainer, and we thought about it, that would be exactly 45 degrees. If we're using this idea, then I have a radius of 1. This is 45 degrees. This is 90. Now you remember from geometry that if you have 45 degrees and 90, this has to be 45. We have an isosceles triangle. This is x units, and my y is also going to be the same, so we can call it x. Remember the Pythagorean theorem that we use all the time? We have x squared plus, we're not going to say y squared this time. The reason is our y direction is x. So x squared plus x squared equals 1. 2x squared equals 1. X squared equals 1/2. And x will equal the square root of 1 over 2, or 1 over the square root of 2. Now, we took the square root of x squared. We're going to get two values. One's going to be positive, one's going to be negative. But the one we want will be the one that's positive because we're moving up. So x equals 1 over the square root of 2. Now you know, don't leave a square root of 2 in the denominator. So we're going to repair it. Now we get the square root of 2 over 2. Now, what is the terminal point? The terminal point, the x-coordinate, is the square root of 2 over 2. The y-coordinate is the same thing, the square root of 2 over 2. So now we have another terminal point that has kind of a unique characteristic, has the same x, has the same y. If we traveled negative pi over 4, we would end up with our x distance being the square root of 2 over 2. But our y distance would be going below the x-axis, so it would be the negative value that we saw a little while ago. Okay, terminal points. Terminal points are found, remember, when you travel a certain distance and you stop. At that location, you want the x and y coordinate to give you the terminal point. If you travel in a positive direction, you're going to travel up through the positive numbers first. If you're traveling in a negative direction, you'll go down to the negative y's first. A whole circle would be traveling 2 pi units. Pi units would be just half the circle. Pi over 2 would be 1/4 of the circle. And pi over 4 is actually 1/8 of our circle. We can find points using pi as a distance. We can find points using numbers other than pi. The pi just seems to be more convenient.